will be the poster session, which is also an important way to convey your research, especially if this research is in an early stage or if you have preliminary results. And it's also very welcome by the community to know where these advances are going. So we have several papers here, and I think we have to be quite strict on time. So there will be no space for questions during the session. Later, we will have time to talk with the authors and ask questions and so on in the session that comes afterwards. Okay. And without further delay, I will start with the first poster, which is an open multi-platform software architecture for online education in the Metaverse by Santiago, Lombeyda, and other co-authors. Santiago, please, you have now the stage.
Hey, everybody, can you hear me okay? Sorry, I'm trying to see if you can hear me okay, and for some reason I seem to have.
We can hear you well.
Oh, awesome. Excellent, I'll get started. So I'm very excited to be here. It's been all the presentations and papers that I've seen so far have been awesome. So I'm excited to get to share our ongoing work with you guys. I love the quote that Nicholas said on the first day, that it's undergrads that are actually building some of the stuff that some of the companies don't seem to be able to figure out. Because in fact, some of the work, all the work that we're presenting today was actually built by first and second year students at Caltech. Basically, it was Anne, Joy, Allison, and Sasha that created some of most of the work that you're going to see here, and I'm excited to be able to talk to you guys afterwards in the breakout sessions. So what did we work on? So what we were trying to do is we were trying to create a digital space that was seamless, that was able to facilitate learning and enable complex lab spaces where you could actually do scientific discovery, scientific learning, all within the context of education and social interaction, which is key to learning. But of course, whenever you're presented with a problem, it's a little easier to tackle it if you have a more narrow definition of the problem. So in this case, Caltech being an engineering school, we decided to, okay, let's focus on complex simulations where it actually helps out to have many people looking at it and interacting, and where there's actually 3D spatial relationships that we actually are trying to understand. So what does it mean to actually try to solve these things of having a collaborative education environment with a sense of presence, and it's immersive, and you're trying to understand 3D structures? So let's tackle that a little bit at a time. So let's start by what we mean by complex simulations and 3D spatial understanding. Well, lots of the work that we do throughout the scientific all scientific fields that we're doing across Caltech usually involves some kind of 3D structure, 3D phenomena. And lots of it actually is being performed in MATLAB. MATLAB is a great place to start. So a MATLAB would be a great place to actually be able to have something that we can look at once together in a collaborative fashion. Some other work, more specifically, that's been going at Caltech. This is, for instance, some results of the CleanUp project, Tapio Schneider at Caltech, where they're actually simulating a cloud and water exchange among large areas of the Earth cloud system. And the 3D structures that we're trying to understand, how water gets pushed up and down different parts of the atmosphere. That 3D structure is actually very hard to understand. So understanding in 3D is actually, at least from a context point of view, before you actually dive into slices, is actually quite interesting and quite powerful. Similarly, we've done things like 3D DNA structures, or even bronchial structures, which I'll talk about a little more later. All of these have these specific things where there is occlusion, where there is some need to see things from in front, from the back, where the cognitive system usually can get stuck if you're not able to really understand what's in front, what's in the back. And a 2D screen usually doesn't do everything for you. So it's really, how do you understand the tree? You don't just stick your head inside a tree and understand it. And seeing it from far away doesn't give you everything either. So there has to be a little more complex relationships and interactions and way to actually see all this information. So that takes us very nicely into VR, AR, or just 3D on screen. How do you move between these environments to actually be able to understand? And hopefully there's tools that we can create for education within these environments. Just as context, we presented this work in SIGGRAPH a couple of years ago, where we're actually using VR to actually create a training data set for finding tumors in the bronchioles in the lung. So it was an environment that was very much supposed to be easy to engage. You could actually stay in the environment for quite a while with a low sense of motion sickness, and you could actually select things. And the depth in information was extremely important to be able to understand and actually perform this task a lot faster than you would do with regular X-rays. So we know that understanding the structures in 3D is possible in VR, but AR would be a great solution. And for some things, actually 2D is also really good. So there's no reason to just select one of these. What we really want to do is, how do we actually start creating a space that goes around this, an ecosystem that lets you actually navigate between all these technologies simultaneously. And not only that, but again, try to go, how do you do this with other people in the same room? And that which is especially key for education, to have an instructor and students and have that discourse between people and be able to talk about it and explain things. Again, we started some work early on. A couple of years ago, we created a virtual reality classroom. We called it the Enhanced Reality Teaching, ERT. It was basically designed with Unity, with the PUN server, the Fun Unity server, to actually create these VR clients where we had students and instructors log into the space. They would jump in. They eventually find a spot to sit on. Then they would have their slides in front of them. They would have a little blackboard to take notes on, and they'll have interaction buttons so they can actually interact with the teacher in an anonymous way, or even answer questions like A, B, C, D. And we would also have these alcoves where people can actually interact and collaborate together. So we created the basic structure for a collaborative space in VR. So now the next step was, how do we tackle and actually start bringing some more complex simulations and visualizations into it? So so we decided to expand it by basically start tacking on some of the basic things that we were talking about, like MATLAB, or when you're studying astrophysics, some of the first classes you take is Astrophysics 101, and they make you actually implement a full planetary simulation in Python. So how about we expose those into the environment? And again, trying to embed those directly into Unity just adds too much complexity. So it makes more sense to actually create a server, a relay server in the middle, where we could tack onto these external applications and then just relay the information to the front client. Again, trying to talk to the PUN server, to the Unity server, and actually try to work with the protocols was extremely difficult. So it just made more sense. It was much more efficient to create our own server. So here's the first example of the ERT concierge working with MATLAB. We have our same alcove that you saw before. You could actually punch in very slowly a formula, and then let's jump there. The concierge would talk via WebSockets to MATLAB, and then MATLAB would spit the information. Similar, we did the same thing with the planetary simulation. And again, you go to these alcoves, you have some ways of interacting with the simulations. You could punch in the masses, the distance to the things, and quickly you learn, if you tweak the mass just a little bit, things just kind of spin out of control. If you push it a little bit in the direction, things just go really crazy. So being able to, for multiple people to interact with the same space and understanding the same information and start really seeing the results of these simulations was extremely useful, especially because it was the original simulations and MATLAB the way you used to do. We just added a small communication layer to be able to talk to what we call the ERT concierge and then talk back to Unity. But what if we really wanted to kind of go a little wider than this stuff and actually have a little more reach? And especially when the pandemic hit, not everybody that we were collaborating with, or all the students, had a VR headset. So all of a sudden, the whole idea of using Unity for VR kind of went out the window. So it's like, should we set up, create Unity applications? It just seemed very very constringent. There was very little space to go. So we decided to kind of switch around and say, okay, why don't we actually kind of rewrite this whole thing and think of the concierge as a hub that talks to services and talks to clients agnostically. So that's where our student Tran came in, and he was just this genius at Rust. And Rust is this language which does memory collection extremely efficiently and communication extremely efficiently. Even though Discord is actually programmed in Rust. So he redid our ERT concierge in Rust, and using a very simple WebSocket protocol. And using JSON basically for the communication, we're actually able to tap into clients and services in a very easy manner. The communication is the way you do most architectures for networks. For like a chat service, you basically connect to the service. Then this service, you say, you know what, go ahead and connect this bot the same way the Discord does, and you connect the service. And then once you get everything connected, the information just starts flowing back and forth very seamlessly and very quickly. So after creating the ERT concierge in Rust, we started creating clients in web-based clients, so Babylon. And again, we tapped back to our planetary simulations, and now the planetary simulation talk to Rust and to the ERT concierge done in Rust, and then you could talk to the ERT concierge in Unity in VR, or similarly talk to the web-based client. But so this is what the web-based client looks like for the same simulation in Python. But notice that the look of it is slightly different, which was what was really becoming really exciting, is that even though we're becoming agnostic to the way we communicate with each of this platform, we can actually do what's best for each of the platforms. In VR, it's the direct interactions where you reach in and you grab an object. But when you're doing a browser, you have the ability to do much more fine control. You have your mouse, you have your keyboard, so that when you interact with the same data, the same simulation, the same thing running in the back end, and both of them could be running at the same time, both the VR and the web client. But you can start creating interfaces that are really taking advantage of each of the individual spaces. Again, loving Rust, decided to create his own Rust physics simulation because he knew it was extremely fast. So he created a Rust game, and here, for this, we see a couple of clients connected simultaneously, and it's a little simple game where you click on one block and you try to destroy the other person's blocks, and you can see that the simulation is running really smoothly across a server. And I think Anne was in Arizona. Our server was in California, not too far, but still, it was running at a really good speed with many elements on the screen. And again, using this very basic JSON protocol and having the simulation in the back end running. So it was a really good proof of concept of how the ERT concierge was actually connecting really well and working really well now with two clients, with the VR client in Unity and with a web-based client done in Babylon. So from there, we decided to try something a little more complicated, and we decided to start tapping into virtual worlds. Now, Second Life is kind of an old school package, but Djorgovski, the leader of a lab, was one of the pioneers for scientific exploration and visualization and having full conferences in Second Life. So we figured, okay, can we just start translating this stuff in a way to connect into the virtual world? So we tried to do the same thing. We tried to connect the ERT server to Second Life, but Second Life uses this Second Life scripting language, which is quite complicated and messy. And even though Second Life is supposed to support WebSockets, it was a little complicated. But turns out that somebody created a bot that actually talks to a middle translator called Chourdas. So we were able to use Chourdas with a small wrapper. Chourdas already uses things. There's a really cool self-artistic bot on the web called on Second Life called Leonardo the bot. So we use the same environment to actually be able to communicate between the ERT concierge and the backend applications and Second Life. So our first test to make sure that that Core worked was a simple aquarium. We had a web-based interface, and you work on the web interface, but the consequences are actually seen in Second Life itself. You add sharks, you add turtles, and they start showing up in our little aquarium in Second Life. So in order to test that, last year, Joey Liu decided to do a physics-based game. There's this game called Brain It On, perfect game for our nerdy Caltech students. And she decided to, okay, what do we have? Again, the basic setup for the game done on a web browser, and then that gets communicated to the RT concierge. The RT concierge talks to a backend Python PyBullet physics server and the game engine, and then the results are actually seen in Second Life. So overall, what we were creating all along was just this central repository to be able to connect agnostically to backend services and front-end clients through just very simple protocol. And the idea is that this really starts creating a backbone to start creating a very large ecosystem where we can actually start thinking of, okay, how can we start really augmenting the capabilities for education and having instructors create simulations, create tests, create educational material, and just bring it up on the web and have it connected and automatically have it live in virtual reality or virtual worlds or a web browser or even a phone. So we're excited about kind of start creating this whole ecosystem, really start creating a more flexible metaverse for education. And I think we're going in a very strong direction. And again, this was all work done by our students. So where are we going with this? Well, we have a GitHub already that you guys can access for the ERT concierge that's done in Rust. We're in the process of publishing the integration with Unity, although we're a couple of versions old in Unity old, and we're using Steam VR, which might not be the best way. So we're actually hoping to move into Unreal. The talk by Mark a couple of days ago got me really excited. And we want to start publishing our basic templates for using things like Babylon, or we're doing some stuff with Android and AR. We want to show more integration with more clients. And we think it'd be a great way to also start creating tools to create these portals a lot faster and a lot easier. And we start creating this exploratory environment quite faster. And the only thing that has been an issue right now is also the audio and video. Pun allowed us to do the audio very easily, but pushing that audio into Second Life, it would be much harder. But there is tools to actually be able to push audio and 3D audio onto the web. So we're excited to explore those as well. So again, this all was work done by our students in the last 3 years, and doing the main bulk of the pretty much all the Rust concierge in the middle. You can access the GitHub at this URL, and I'll share it again in the room. And we want to thank all the people that helped fund all the work and support our students and get us some free hardware to actually be able to play with the stuff. And I'm looking forward to talking to everybody in the breakout room if you want to join me and ask any questions. Thank you.
Thank you very much, Santiago. Great work. So we continue with the next poster called Document Segmentation for WebAR Application by Thibault, Lelong, and co-authors.
Okay, so hello. So I'm Thibault Lelong, and I'm PhD student at Telecom Sud Paris. So today I'm gonna present you a solution for document segmentation for WebAR or just web application. So actually, why we need to document segmentation. In several cases, we have to recognize some document, or we just need to analyze the document. So for that, we use a deep learning approach. So in this case, we develop a new architecture for document segmentation, which will light and fast for to be usable on a browser. So we start to select this challenge, which is released in 2015. Actually, there are two objectives for this challenge. The first one is document detection and segmentation, and the second one is how to extract information from this document. So, like with some OCR algorithm or some stuff like that. So actually, this database is divided into 5 categories, and there are 25,000 images. So the problem in this database actually is that all the images look a little bit similar. So we decided to develop synthetic data from Blender. So we use a document dataset with the background dataset, and actually the advantage of the Blender is to add some document deformation, occlusion, or just you can move the light source. So we generate 20,000 images for complete our trained dataset. So the next, we start to study the impact of the when you delete some convolution layers. After we try to optimize the encoder and decoder part of our model, and finally we try to evaluate the impact of this model on cloud recognition system. So for all the model that I will present you, we use Adam optimizer. We set a batch size at 6, and we trained all the model on with the 60 epochs, and we use dice loss function. We also use IOU metrics to evaluate all the model. So we developed 4 models. The first one was UNet, which achieves the best result on this challenge with the HUPage scan. And we develop 2 more models where we try to delete some convolution layers. So actually, in this 4 configuration, the results are quite similar for a significant, but there are significant decrease in the number of parameters and inference types. It's divided by 46 between UNet and UNet Lite 2, the last one, and the inference time was divided by 4.5. So the first optimization on the encoder part is just to remove some max plane operation, and we replace we use convolution with the street at 2 for reduce size. The ResNet model use the same optimization for that on their first layer. For the decoding part, we add a series of dilated convolution to increase the restricted field that we lost with when we delete some convolution layers. We also add a notation block in the decoding part with the channel and spatial attention So finally, no, our model is have actually 768 parameters. So it's pretty good result at finally, and it can run on a browser and in my MacBook Pro, for example, you can run on and get 125 FPS. So if we compare with the state of the art, HU page scan actually, our model divides the number of parameters by 10, increase the speed by 4.8. But the difference in accuracy is lower than 0.01. So this is some example of prediction from laptop, not in browser actually. The results are pretty good. In this slide, after we convert our model from PyTorch to TensorFlow. So we have to use ONNX and Keras framework. Actually, the model is pretty light, and it can run on iPhone trace. You need 0.06 seconds to make a prediction. The results are good, but in sometimes there are some errors, particularly around the document. But it's actually usable in industrial application. So we try to evaluate the impact of this pre-processing algorithm in a cloud regression system. So we develop a pipeline with the SIFT and RAD features. We use a database with 50 business cards and 100 query images. So all the prediction will be run on server. Actually, we evaluate the global descriptor on top 10 candidates with and without segmentation, and we obtain 25% of accuracy for the top 1 result. So we finally to conclude, we get a light and fast model, which is pretty close to the state-of-the-art model. It's actually usable on the browser. I think that we need to improve the database actually and increase the diversity of the document. And I think that good work to be done is to try to develop end-to-end model for developing the solution directly from the browser. So that's all for me.
Thank you very much, Thibault. So later we can make some questions during the pause for this interesting application. So let's go for the next poster, which is called Visual Rehabilitation for Learning Disorders in Virtual Reality by Lea Saunier and other co-authors. Yeah.
Hello, hello. Okay, hello everyone, I'm Lea Saunier. Can you hear me correctly? Yeah, okay. So today I will present you a work on visual rehabilitation for learning disorder in virtual reality. And the disorder in question in particular is dyslexia. So I will introduce dyslexia quickly and talk to you about the existing therapies. Dyslexia is a neurological disorder that affects around 10% people in the world. Maybe some of you here are affected. 1 dyslexic, 2 dyslexic. Perfect. You will be the perfect candidate for testing during the poster session. So it is known as a reading disorders, but it can also affect spelling, understanding, and pronunciation. You see, I'm not dyslexic, but I still have problem with that. It's part of the dys neurological disorder, dys meaning difficult in Latin, and lexia, reading. In the same family of disorder, we have dysphagia for oral language, we have dyscalculia for calculation, and dyspraxia for coordination. Those disorders do not affect, in any case, the intellect of the patient, but they affect very precise cognitive function, and sadly, they can be present at the same time in the same patient. For dyslexia, we can detect it quite early, usually when children start to learn reading and writing. So depending on the country, between 5 and 10, they can start therapy. Problem is the classic therapies rely on repetitive, time-consuming, and let's be honest, boring tasks. So it's a pen and paper approach. They have to go once or twice a week to a specialist. They have to do work on top of their homework. So for children, most of the time they give up the therapy, which, not even talking about the efficiency of the therapy, because of the lack of adherence, we have a huge problem. To tackle this problem, we are creating new kinds of therapies, the virtual therapies, and especially virtual reality therapies. Here are a list of very interesting works. They are quite close to ours and present a list of features that inspired us a lot. And in these features, we have here in the first example, we have multimodality. This first example uses both vision with eye tracking in the reading and audio with text-to-speech. So both using vision and audition as a mean to treat dyslexia. The second project introduced a very, very important feature, which is gamification. We are talking about a very young public, usually, for these kinds of therapies. So, as I said, lack of adherence because of boring tasks. We want to exceed the boring, bring in the fun. That's where gamifications come in. So instead of having a therapy being suffered through, we want the children, the patient, to play a game which will actually help them with the symptoms. And then the last one, which is full VR therapy, with that I mean with the headset, uses another feature that interests us, is VR features, as in the whole immersion, the body movement, and the hand movement. This study in particular focuses on eye-hand coordination. So all those projects are works in progress, like I said, just like ours. So we can't really say much about the efficiency of the therapies, but we can already extract one big improvement, is the huge leap in adherence of the patients. They don't suffer through the therapy anymore. They want to play it. And in some of the studies, even the control group, that is to say the non-dyslexic children, wanted to do the therapy because they wanted to have fun with it. But to our knowledge, no therapy currently combine virtual reality, multimodality, and gamification. That's why we bring our own VR multimodal prototype. Okay, so our prototype was made with a group of orthoptists, eye doctors, and a neurologist, which is also an author of this paper, who together brought the ideas of switching from the classic pen and paper exercises to the VR 3D ones. And to do that, we used Unity, which is a game engine that some of you may already know. If you saw yesterday's conference with Epic Games, you know about Unreal. Unity is one of those game engines that allows us to develop this therapy as a game and allows us to have all the tools for VR. And for the hardware, we use the HTC Vive Pro Eye, which is a VR headset that is adjustable and with integrated Tobii eye tracking. Very important for us, we want to have eye data for analysis and for inputs. So as I said, we prepared exercises for a prototype with our doctors. we prepared 3 types of exercises: the visual exercises, the exploration exercises, and the reading exercises. The first kind is visual exercises. So why focus only on the eyes? The question of reading trouble and dyslexia is actually quite thorny still today, because you can be born with dyslexia, but you're usually not born a reader unless you're a genius. So the question of reading trouble being the cause or the symptom of dyslexia is still a huge debate that I will not solve because I'm not a doctor. But there is no question about the fact that dyslexic people have different eye movements during reading and during all the tasks. So we want to work on those symptoms and focus on the eye movements. The first one being the continuous pursuit. I hope with the connection. Okay. In reality, it's much smoother, the movement. So please come to the demonstration afterwards so I can prove it to you. The idea here is to follow a smoothly moving object. Dyslexic people tend to have saccadic eye movement when trying to do smooth pursuit. So we want to improve that to have smoother eye movements. And thanks to VR, we can work with vertical movement, lateral movement, and what we call vergence, so depth movement. We can also work on peripheral vision, and we can work on gaze tracking, that is not just eye tracking, but your whole gaze with head and body movement. So we can work on the impact of those body movement on the vision too. We also have saccadic exercises, which are very, very important because reading for dyslexic and non-dyslexic people is all about saccades. When you read, you're moving your eyes in saccades straight forward, then go back to the line and then straight forward, letter by letter, word by word. Dyslexic people tend to do a lot of retrosaccades, that is to say, coming back a tiny bit. It's very, very little movements, but those little movements make the read way slower and has a huge impact on the reading quality. So we want to work on the saccadic movement. Here the idea is to look at an object that is teleporting around and to have only saccadic eye movement, but more straightforward. Then we have the focus exercise, because dyslexic also tends to, even at rest, and at rest I mean, if you try to look at a point, you will mostly look at this point and focus on that point. Dyslexic people tend to have tiny saccadic movement even when they try to focus on a certain point. So here we try to work on that focus by introducing distractors. Thanks to VR, we can work with 3D distractors, as you can see, the big red 3D objects. And those objects can move around the person, move around in 3D, move around in depth, and we can also play with the environment and the characters as distractors. Then we have a new kind of exercise, the exploration exercise. In the current approach, the pen and paper approach, think of Where is Waldo? For French people, Trouver Charlie. This is the kind of exercise they have to do. On the paper, find an object among random objects. In our case, we're working with 3D object and 3D environment. And this is not random object put in place. We try to recreate an environment where we have to find those 3D objects. We can work this way on visual search, 3D visual search, and a bit of spatial awareness. Here is another example with another environment. Why so many environments and so many characters? Remember, we're talking about a gamified therapy. Those tasks will always be repetitive, let's be honest. But we want to stay fun with those tasks, and in between session, one solution to keep the attention, the adherence, and the fun for the patient is to have variation in the environment and the objects. And here is a level 2 exploration exercise. As you can see, the environment is a bit more complex, and we have more objects that act as distractors. And very important, in this level 2, we want to introduce spatial awareness so that you need to move around, to look around, not just stay in place to find the last object. So we want to study the impact of this full 3D environment, like 360 environment and body movement and spatial awareness on the rehabilitation of dyslexia. And then finally, we have the reading exercise. Just like our doctors today, we won't be using it as a core and repetitive exercise. We want to use it as an evaluation after a session or after a group of sessions. The idea is to have this text that is close to the person, that they can move at the distance they want, written in a special font called the Luciol font. Maybe you've heard of it. It's a special font for people with visual impairment, not just dyslexia. And we write this text. The patient has to read it. We have the eye tracking to check on the visual quality of the reading, as in retrosaccades, etc. And then we have, very important, the understanding question. Very difficult, as you can see. The idea is to both evaluate the quality of the reading, the evolution of the reading in terms of visual quality, but still keeping the understanding cognitive function. So that's it for our prototype so far. But we have many perspectives of evolution, especially in the development of the application. One thing we want to do first is develop a full medical protocol to make it one full therapy that we can actually test in clinical conditions with different groups, with control groups, with a comparison with the 2D therapy, with maybe other kinds of therapies that exist. And we want to make one therapy, one adventure for the children. So we want to use game design also as making one therapy, one full scenarized application, with rewards and advancement, as it is proven that it helps a lot with involvement. We also, of course, want to improve the current exercises with more levels of complexity, with different environments. And we want to add more exercises. Especially, we want to work a bit more with multimodality, so with body movements and, if possible, with audition. And actually work with everything that VR has to offer and study those impacts of the new VR environment, the fact to be in 3D, the fact to be using your whole body, to using multimodality. And to analyze that, we also want to develop on the interface side with the adding of brain-computer interface. Don't worry, we're talking non-invasive electroencephalogram. It's just a cap you put on your head. It's not painful. You barely feel it at all. But it gives us a lot of information on two very important evaluations. The evaluation of the patient. So how is the patient evolving during the therapy? Where is difficulty? And can we adapt the therapy to put more exercise where he has difficulty and less exercise where the patient is already good at it? And the second most important evaluation is that we can evaluate the therapy itself, thanks to EEG and eye tracking data, to see, is this small modality helping? Is this exercise helping at all? Maybe yes, maybe not. So EEG plus eye tracking is there to give us an evaluation of the patient and an evaluation of the therapy. So thank you for your attention. Feel free to come afterwards during the poster session. There is a VR demo of our prototype that is not only for dyslexic people. Everybody can test it. So feel free to come in. Thank you for your time.
Okay, so thank you, Leah. Excellent work, and I will try it for sure. So, okay, so we have now the next poster, which is called Spatial Audio Designer by Nicholas Polis and Noam Bendelac. So please come to the stage.
Super. Thank you so much. Good morning. It's a great treat to present this work, which is another result from our senior capstone class. And I wanted to thank my co-authors and, of course, the rest of the student team who have put this together. And it's my pleasure to present their work here to you. So, as I mentioned yesterday, we have given our students in their senior year a menu of projects and challenges that they might tackle as part of their design, prototype, evaluate method. And this group targeted this idea of spatial audio design. So we have a very excellent multimedia and art department on campus, and as you may have seen, several great galleries and spaces. One of the things that of course, is a key to the experience of space is the experience of audio. And so when we have artists creating an exhibition, right, they're also considering not just the lighting and the placement of the artwork, but also the ambience and the sound. This is also true in some of our spaces where we have, you know, speakers all around the gallery and the room, and we might be even using some more advanced types of mixing amongst these speakers to create different audio experiences in different parts of the space. And as this is a design platform, it really became motivated by the artistic side and the effort required to design these kinds of audio environments, immersive audio environments. So we're thinking about an installation, and where the students went and talked to several practitioners and faculty who build these sorts of environments, and really trying to understand, you know, what are the requirements and the challenges that they face. And so first of all, of course, the sound sources have many different properties, and we'll talk about a few of those here. But of course, they're located and maybe even pointing around at different locations. They might have different widths of coverage of that audio signal. And so it becomes really important to use that space, place audio sources, and then walk around and see how it sounds, right? And this is, of course, a 3D problem, but a lot of the tools that are existing now are quite high-end and complex and frankly not very accessible for non-technical people. So the team decided to use some of the web-based technologies, for example, the Web Audio API from the W3C. And the student group, actually, I see Athanasios and Brutzman here on the line. Their paper from last year was a great inspiration on how to bring web audio into 3D environments. And just a quick kind of summary of the basics, right, is that we have sound sources, which have lots of different properties. I'm sort of illustrating this here. Obviously, it's an orientation. You have this distance, and also an attenuation factor, which is this inner and outer cone, okay? And then that is perceived or sampled by a microphone or an audio listener, right? Which also has a direction in 3D space, 6 degrees of freedom. Okay, so essentially you have a number of properties that would be of interest, right, to manipulate. And some of the things that we want to portray, right, the sound is invisible, right, but we want to have some kind of a way to see the effects of our manipulation of these different parameters, okay? And when we try to think of how is the sound propagating through the space, right? You can see we're kind of talking about a radius and an angle off of that Panner node, and then that becomes the value of right, the audio signal at the listener. Okay. So we did want to give a way for the non-technical artists to manipulate these different parameters. And some of the ones that we decided to expose were this, distance and attenuation factor, and also its position and orientation, right? So we know we have 6 degrees of freedom just in the position and orientation, but then with the inner and outer angle and the attenuation, that's another 3, okay, degrees of freedom for each sound source in the space. And so it became a challenge of 3D user interface of manipulation, right? How do we manipulate all of those different parameters, maybe when we just have a mouse and a desktop, okay? So a few of the designs that were naturally came up. One of them was, gizmos that might be in the 3D scene, right? So we know of, in a lot of our authoring tools, you grab a plane, you can drag the object along one of the axes. or you know, you click on an object and there's a bunch of arrows that tell you how to rotate maybe the object. And this is seems to be you know, useful for certain kinds of manipulation if you're in 3D. Okay. Also, of course, the literature will tell you very quickly that it's very imprecise. You know, it's a lot. We have lots of jitter, not just in the tracking, but in our hands, right? So if you're talking about trying to move something a fraction of a degree, you know, good luck. It's a lot more efficient to just type in a number or use a 2D slider, right? It's a one-dimensional problem, but you're trying to do it with 6 degrees of freedom. So these ideas of gizmos, manipulators in the scene, was a natural one to start with, right? We've seen it before. And then you also have the contrast, which would give you more precision and control, which is just a simple slider, okay? So these were the 2 features that two of the aspects that the students wanted to prototype. The other was, how do we see the effects of our manipulation, right? And so it became pretty quickly that we needed a way to kind of show lots of different sound sources being combined and their effects in the space, okay? So we, the students again, designed came up with 2 essential approaches. You know, one is a polygonal-based representation of the sound cone, right? Maybe with some transparency to tell you about its strength. It also shows, you know, some distance. And the advantage of using cones to show the audio propagation, right, is that, well, they're discrete. They have some boundaries. But then really when we're trying to add up the effects of multiple sound sources on a space, it becomes very confusing and difficult, right, to disambiguate where the sounds are coming from and how. So the second aspect, the part of the prototype and design that the students used was to create a heat map. Okay, so this would be a way to look at the scene that actually does show you all of the combinations of sound at a certain location. Okay, so the brightness of a sound, or the brightness at a location will tell you the loudness of the sound, and you'll see on different surfaces, right, the exposure of that surface to the sound field. Of course, this has the downside of, well, if you had a material there, now it's replaced with the heat map data, right? So it kind of impedes the scene. So a quick thing about the implementation. The students were excited about Three.js. They had a little bit of background with shaders, but they had a few challenges, and in this learning curve was a bit steep, actually. And so the Three.js 6 degree of freedom manipulators was not actually implemented due to this difficulty. But they did use some common libraries that we would recognize, obviously having web audio, using React so that we can have this consistency of interaction and components on the page. And they also used TypeScript, which was, I should also say, a bit of a learning curve as well. So it has some benefits, but it also introduces quite a bit of overhead as well if you're learning this from JavaScript, right, for example. But that's a little bit about the implementation. So you can kind of see the mock-up of that first design. Right, we have the transparent cones showing you the different audio aspects of the audio field. A speaker represents the sound source, right? So we're looking again, here we are in Sponza. And then a panel of 2-dimensional parameter controls. Okay, so you can go through and click a speaker. It will tell you what the track is there. Maybe it's the cymbals or a drum. Being able to change between different views of the sound field, open or save your scene. These were some of the key, right, requirements they had derived for a sound design application. And then you can see a bunch of sliders to pull on different parameters. Okay. So this was sort of the, let's say, the naive representation of the sound field. It does give you certain kinds of information, also hides some, especially that idea of multiple sound fields combining. So here's the example of the shader / heat map version. Okay, and here we are again, like summing the sound field's effects on a surface using a shader and heat map. And again, we're casting from each of these sound sources into the scene. Okay, and you can manipulate each of these in real time through the web interface. Okay. So here's, if you wanted to check it out, anybody online, I know you may want to play with it yourself since you won't be in the physical poster session. But I invite you to take a look at it, provide us some feedback. Certainly we would like to expand some of the functionality here, being able to add other kinds of scene content would be fabulous. The next sort of thing would obviously also be, can we use the geometry to understand the real effect of the sound, right? For example, echoes and reflections and things off of the geometry in the scene. Right now, we're not taking any of that into account. So I look forward to sharing our work with you, and thank you for your attention.
Thank you, Nicolas. Great job. So, and it reminds us that Web3D is not only about graphics, it's also about sound and interaction, multimedia in the internet. Okay, so we continue with the next paper, which is, sorry. Sorry. Okay. Which is deep learning classification in Web3D model geometries by Chrysoula Tzermia, Nick-Periklis Chourdas, and Athanasios Malamos. And Athanasios Malamos is joining us online. So,
good morning, everybody.
Thank you.
Okay, I have opened my microphone, yes. Good morning, everybody. I'll take the first 2 minutes just to inform the community that most of you, I know that you already know that spatial sound is part of the X3D instruction set now, and also it is included in the last X3D standard, which will appear shortly. And also to say that we are in a good right now. We are preparing also implementations of the language. I mean of the instructions into several platforms that host right now X3D. So I will be happy if next year we have also more things to say about that, and this is our effort because we are working together with Don Bratsman and other colleagues in this direction. Now, about our paper, our poster that we are going to present. Do you see my presentation now?
Yes, Athanasios, we see it.
Okay. So what we did, and we would like to share with you, is that we were working in a classification of 3D models, which, you know, all of us, we know that it is one of the, as I say in my presentation later, one of the all-time classic problems. We are working in this subject because we feel that an essential subject of the future. That's how we see this. Let's see what we have done first. So in this paper, we focus on classification of Web3D models, in particular X3D formatted models with deep learning algorithms. We explore the requirements of Web3D models, in particular X3D formatted models, as I said, in order to work efficiently with deep learning algorithms. We make experiments on classifying X3D models that are inside X3D scenes. So we have also somehow to segment the scenes in order to extrude X3D models out of them, and then to go on with classifying these exact models. We used a certain deep learning algorithm, which is called PointNet, and is one of the latest algorithms in this area. And finally, we make a brief comparison between two of the most recent algorithms, the MESNet and the PointNet. They are both algorithms that appear in the literature the last 3-4 years at most. The first one is for meshes and the later for point clouds. And we prove that both may work very well in case of enhanced X3D models. Enhanced X3D models are X3D models, of course, but with some enhancement, as we will see later, on increasing the number of points in the case of PointNet, or increasing the number of triangles in the case of MESNet, which is something that can be done in real time with, let's say, plain and easy to implement algorithms. Now, in our experiments, we train and test with mixed kind of models, like training with point clouds, for example, and testing with meshes, or vice versa, and also testing with models found not only inside the data set, but also outside the data set. And this is because we like to see, to check the robustness, as we say, of our proposal, of our solution. Now, the motivation of this work was, of course, as I said, 3D model classification is all-time classic problem. Colleagues like Marius, for example, with MPEG-7 knows very well that many years now we are trying to annotate and classify and annotate, obviously, 3D models, many of us. On the other hand, using deep learning in 3D model classification has gained many attention lately because of the cloud technology and the new algorithms that make feasible to get good results in almost real time. So the technology, help us to improve our solutions. Semantic segmentation and classification in 3D scenes may assist in projects like autonomous vehicles, as well as in metaverse environments that we all discuss about the last few days in this conference. X3D is a major, on the other hand. Why did we choose X3D to do our work? X3D is a major Web3D framework with a semantic-friendly description, thus very appropriate for its 3D models representation. X3D remains to be let's say, a declarative, as we all know, a declarative 3D expression. On the other hand, we have tested several times, and for many years now, we have tested its ability to include annotated data models inside, and it is, in my opinion, and in opinion of many other people as well, one of the best semantic-friendly 3D description. Web3D appears to be the future, especially after the attention gained by major players in the universal IT economy. In this conference, we had an extended discussion about it, so everybody is well known. It's something well known and very well covered. Now, classification of 3D models and scenes in the web may initiate new services of the future metaverse environment. It is what we believe that it is going to be a part of the future anyway. Now, our conclusions about our research. So in our research, we conclude that the X3D models, which are, we know, lightweight because they are Web3D models, require some vertices enhancement in order to cooperate with deep learning algorithms, and we suggest algorithms that may be applied and make the whole process in real time, which is very important in case of web applications. The results also are very encouraging, and easily we may achieve positive predictions up to 80% or even more sometimes. Another contribution of this work is that we prove that point-net algorithm can be used for meshes as well as for point clouds, having similar performance to one of the latest mesh classification algorithms. This is very important, I may say, because simply we proved that one algorithm is appropriate for both types of graphics. And I explain you why it's important. Point clouds are produced usually by sensors like laser scanners, like cameras and photogrammetry and stuff like that. On the other hand, we have usually some meshes, as we all know, which are synthetic more or less, or either created as clouds, but someone, I mean, software or even some person, some engineers, improve these point clouds with meshes in order to be, let's say, easier to handle. These two types of 3D models may coexist, may appear at the same time. For example, in a vehicle that you have a scanner, and at the same time you have some kind of database with some pre-processed models in order to match or to train, for example, your neural network or your deep learning algorithm, etc. So that means that, okay, this means that, okay, one algorithm can handle both of them, means that one algorithm can handle any type of different 3D model at the same time. So we believe that this is a serious contribution of this work. Now, even more, we show that even sparse meshes, like the Web3D meshes, can be classified with deep learning algorithms. This conclusion creates new opportunities in the use of X3D as a modeling platform for both synthetic and real-time scanning created scenes. So I have also a QR code where you can give you the URL to go and see the poster site, because we don't have physical sites for physical posters. Okay, so you can follow this link and go there. I will also, and I'll give you a hint about the website that it is the poster for this conference. I think it is the website right now in the screen. This is the website where you will find a few things about our work, you know, with the examples running in real time. First of all, we have some links on top. This is a video of about deep learning in 3D geometries that you can attend later. Which is part of the tutorial we had in the first day of this conference. Also the paper that we sent to ACM, and finally we have all the source code we use in order to train, to develop, train, and then check, test the algorithms. Okay, so we have all the source code available. Now, we tested, we make several tests with different different models, but in this case, for the poster, we created 4 different scenes that just for showing that all this process can be made in real time. So assume that we have already created the neural network, the deep learning algorithm. In the tutorial, we have give all the details required in order to train a deep learning, and then to create it, and then to export it in a web-friendly format using TensorFlow.js to run it and to use it in your web pages. So you can follow the video there and see how you can do it, with what tools you can work, and etc. The thing here is just to make a demo of all this effort we did. So let's go to scene 2, for example. Okay, the scenes are dense enough in points, but not that much. I mean, 9,000 points are dense enough, but to work with, but they are not so dense anyway for a 3D expression. Of course, in the bottom of the web page, you will see the results of the test we did. Okay, for different kind of classes, different kind of objects, 3D objects, and the different level of detail of the 3D, X3D files. Okay, here, imagine that here we have a scene with all these files together, all these models together. Okay, and some of the models are, as I've said before, from inside the data set, the official data set. The official data set is model 40. It is an official, but about all this you can see the video, or you can read the paper as well. Now, the first thing is from the scene to extract the models. This is the first thing you have to do. So you are creating bounding boxes. We pop up here how many milliseconds we needed to create these bounding boxes. So of course here, since it is an X3D, as I said, it is very friendly, semantically friendly. So as it is an X3D, the extraction is done by using the structure of X3D, taking advantage of the structure of the X3D, which is very friendly to this. As you will see also, we are creating bounding boxes and we visualize them. It is clear. We have these models inside the scene, so we decided about. And finally, we are running the algorithm just to decide which models are in the scene. So you find here there are 2 panels. The first one is with the correct, and the second one is the wrong predictions, but it also gives you a hint of okay, it is wrong, but what really predicts? What faulty were, of course, but what really predicts? So as you can see, it predicted in real time, because this is running every time you are calling this web page. Okay, and of course you can use our source code in order to change the models and check your own scenes, of course. Now, for example, it predicts there that there is a stand, a desk, a plant, and a laptop. Okay, and these are the right predictions. Okay, the wrong predictions was, for example, that a chair was predicted as a sofa. So it believes that this chair over there is a sofa. Wrong prediction, that a bed is predicted as a chair or something like that. So these wrong predictions, of course, may help us to improve our algorithms and so on. I mean, this is the way we are working anyway. About okay, so if you, I hope you managed to see the link. I can put it in the chat as well. Okay, and it would be great for us, you know, to find other colleagues that they share, let's say, common interests, so we can cooperate. We are giving you the dataset, we are giving you the source code, and if you like, we can cooperate in this and go on together. So that's it for the poster presentation for now.
Okay, thank you, Athanasios. Please, an applause. Thank you for this interesting approach of combining deep learning with X3D models. And then we have now the final poster of this session, which is challenges in enhancing augmented reality operation with deep learning-based object pose estimation for industrial manufacturing by Hugo Durchon and colleagues.
Hello, everyone. Can you hear me? Okay. This work is in collaboration with Bosch, a Bosch factory, where human operators are manufacturing boilers. Depending on the business need, this factory is employing a lot of temporary workers. So the training procedure of operator is a crucial matter. Augmented reality is a good medium to create this training system because augmented reality can interactively display instruction to operators and help them and guide them during the assembly. It has been shown that augmented reality can improve the quality of the training by reducing the number of assembly errors and by reducing the cognitive load of operators. This cognitive load decrease is linked to the fact that AR can display the right information at the right time and in the right location. So in our factory, we notice that user experiences is really important to help adapt and adopt the AR to real industrial scenario. Okay, so currently the Bosch factory is using an homemade augmented reality system, which can be split into two parts. The first one is an authoring instruction tool. So basically, an expert operator will create all the instruction. So he can manipulate like text, virtual content. So this virtual content can be text, images, or even 3D models. And he will create like the assembly procedure. Then novice operators can play this instruction to learn the assembly by themselves. So for instance, the novice operator will put an headset and then he will see the first instruction, do the correct action, and then click on next button or use a voice command to display the next instruction. And thus all the assembly procedure training will be done. So the best interaction modality, the best virtual content, and the best UI I've been already tested with operator. So now if we want to further improve interaction with the AR system and user experience, we would like to add computer vision to have interaction as natural as possible. So the ideal case will be to have like seamless interaction, like when we are interacting with real objects. So one of the pain points of the current tool is that the authoring tool for 60 instructions take 1 hour. So it's a bit long. So we would like to have virtual content placement of the virtual content. Moreover, the scene is dynamic. So if some objects are moving, the virtual content won't be relocated correctly to the scene, to the correct location in the scene. So it will create misregistration and confusing operator. So both of these problems can be solved thanks to pose estimation of all objects in the scene. Another point is that we would like to detect an instruction has been performed to get rid of the repetitive next button action, and overall detecting errors and provide personalized feedback to every novice worker will be very nice to for quality control and training effectiveness. So I will just quickly describe you the production line in the factory so you can understand well the context. So on the left images, you can see the wall line. So the line is approximately 3 or 4 times the size of this room and got a U shape. And several workstations are along this U shape. So the boiler is built upon a lifting trolley, and the lifting trolley is set to a yellow rail on the ground, and the human operator are pushing this trolley and the boiler during the assembly. On the right, you can see a supermarket where like all the assembly parts are stored. And this kind of assembly line can be reconfigured depending on the model of the boiler and on the need of the industry. So it's not something that is fixed. Like we can't do just a slam of the environment and say the work is done. So it's not like that. The first constraint of the environment, if we focus on the boiler, is that the lifting trolley can be elevated or tilted depending on the assembly task to do. So this means the 3D position of the boiler is evolving during the assembly. So when we want to place virtual content around the boiler, when the boiler is tilted today, the virtual content will not follow the boiler. So it's an issue for the user experiences. A second constraint is that the boiler is an evolving object. So we will use deep learning models, and it can be complicated because on the left, you can see the first step of assembly. It's just the main structure of the boiler. And this object is really different to the white object, like the complete boiler with hydraulic and electronic circuit. And the last constraint is more material and factory oriented, because we can only use HoloLens 2 to capture data. We can't like fix capture in factory or use internet connection for like factory constraints and reproducibility and sustainability in factory. So now we'll focus on object pose estimation, but only of the boiler. So to solve this, we want to do AR markerless detection and tracking of the boiler during the whole assembly process. I will just recap quickly what is augmented reality registration. So it's the task of aligning virtual content with the real scene so that users see spatially accurate information. So this task can be split into 2 parts. The first one is to do camera calibration, so to get camera intrinsic parameter like focal length. Nowadays, Microsoft and Vuforia and big AR libraries is doing it, so it's no longer a problem. The core problem is to do detection and tracking to succeed to get the pose of the object of interest and then get the camera expressing parameter to do the alignment correctly. So now we focus on this area detection and tracking method. Currently, the Augmented Reality system is using a marker-based method. This method is really efficient and well spread in industry. But because in our case, the environment is dynamic, it's not enough because we can't like put 100 marker in the whole production line. It's just not feasible and sustainable for the industry. So another class of method are called markerless method. So they did not rely on a non-feature, on adding a non-feature like marker-based method. So traditional method use SIFT or this kind of descriptor, but they are weak to elimination and complex shape object like a boiler. SLAM-based method, as I said before, are better with static scene, which remains the same. And model-based method require exact CAD model of the object for any step of the assembly of the boiler. And it's definitely something the factory don't have and can't provide. So we will turn to deep learning-based method because they are known to be robust to complex environment, and they can help us tackle with the complexity of this problem. So from deep learning point of view, we can formulate the pose estimation, like the markerless detection task, as 2D object detection, 3D object detection, or 6D pose estimation. So in our case, we will select 6D pose estimation because we want the exact pose, so 3 translation and 3 rotation of the boiler in real time to be able to relocate the virtual content. So the idea is that we need to have images of boiler with 6D pose annotation of the boiler, and we want a deep learning model predicting the correct pose. So we want to do that for boiler at any assembly state. And this is a preliminary experiment. So the idea is that this task is really complex. So first we want to try to create a kind of benchmark and see what we can do with more constraints possible and with like just simple RGB images to show first to be able to have first evaluation and see how much work and what will be the cost to have really a really efficient model to do this task. So that's the goal of this experiment. So quickly, the overview. The first part was the dataset creation. I will talk a little bit more in the next slide about that. And then model selection and training and the evaluation. So for the dataset creation, getting images of boiler is kind of easy. The real pain point is getting 6D pose label. So to try to facilitate this process, a first idea was to put QR code on the boiler, but only during the data capture phases. And then we can apply like a QR code pose estimation algorithm to have just 6D pose label. So it's not like a traditional R marker-based method. It's just to in order to get all labels because 6D pose label are painful to get. So once this is done, we want to get rid of the QR code because at inference time and during reality, we won't have this QR code, so they will skew the model. So to do that, we apply an in-painting process with a generative neural network called DeepFill. So in the end, we got 6D labels and clean images without QR code. So for the model, we use MobileNet V2, which we tweak a little bit to be in a regression scheme. So we add linear layer to predict numerical values. You can see in the table all the parameters, but because we are running a bit short of time, I think we can see that during the poster session for the parameters. For the evaluation, I use average distance diameter, HAD metric, which is commonly used in object pose estimation. The idea is to calculate the average distance between the predict pose and the ground truth. Then, if this distance is under a threshold, we consider the prediction correct. we often set the threshold to 10% of the diameter of the object. So here, the lack of robustness of our result can be explained because we failed to generalize to unseen data. So one of the main issues is that our data set is of 6,000 images. So we have not enough data, no synthetic data, because it's really hard to create synthetic data of industry without 3D models. So basically, we have not enough data to describe all the complexity of the scene. Another potential problem is that we directly try to apply a lightweight model because computation must only be done on HoloLens 2, which is an embedded device. And then the background is really cluttered and the object is reflective. So probably RGB data is not enough. So now the future work perspective. First, we want to finish improving this preliminary experiment to really validate the fact that we can't do 6D pose estimation in this case with only RGB data. So mainly we will add an augmented reality pose estimator that will help us with the 6D pose annotation. So the idea is to place a 3D bounding box in AR around the object. And from the box, it's really easy to retrieve the 6D pose level. And in bonus, we can get the object dimension, which can help us for the prediction. The second step is to add a depth data thanks to HoloLens 2. So HoloLens got 2 depth sensor and spatial mapping capability. So the idea is to create this kind of roof model, 3D model, and then use them as input of the network, but also create synthetic data with them. So we really need to synthetic to do generation of objects, but also views, because having several views is important in this problem. And the last step will be to add state estimation. So to do the full use cases. So to my knowledge, I have only found one article applying pose estimation and state estimation in augmented reality. So you can see on the right images, the idea here is to do like assembly, but of a simple coffee machine. And here they are able to do the pose estimation and detect errors. So we want to do the same thing, but with our boiler, which is more complex and with more assembly states and in a dynamic environment. So to sum up, we define the use cases and industrial constraints, and we will try to do that to really apply augmented reality to industry, because our assistive systems for industry are not new at all, but in reality, they are not really applied to industry. So that's it for me. Thank you for your attention, and don't hesitate to ask me questions during the poster session. Thank you.
Thank you very much, Hugo. Okay, so thank you to all the poster presenters. Now we will have a session where we can interact with the authors of the posters and also talk about other things such as industrial cases and so on. So please, let's go for that session. So. I think it's in the exhibition hall, right? So we should move to the exhibition hall. Okay, please.
So for the online connection, you have in UVA 6 links for the 6 presenters. You can choose any of them. And here on the setting, we have 6 positions with computers, so you can also see the persons that are installed there. If you have any trouble, just send an email to me or to Patrick, and we will figure out how to make you connected. Okay? See you in the poster room. Okay. Just a quick check with people online. Can you hear us? I cannot see your faces. Let me see who is online. People. Don is not anymore with us, but yeah, Don is with us, but we cannot see his camera yet. Just a confirmation from someone online that you can hear us. Write it in the chat window or no, but we have some people online here. All good, great. Thank you, Edward. Let's start. Okay, so we are now in the last session before the lunch break, and this is a Web3D Consortium dedicated session called Web3D Town Hall, and we will have Nicolas and Anita giving us some updates on what the consortium did in the last time and what are the plans for the future. Thank you. Nicolas, please take the microphone.
Thank you, Marius. Thank you so much. Yes, it's a great treat again to be here together, you know, our annual conference. And it's great to see a lot of old friends and familiar faces. This is a community that has been working in interactive 3D graphics, making real products, real demonstrations, real applications for over 2 decades. And so it's a really exciting place to be. And I would like to have a little time today to share with you a little bit of what the organization is about and what it's doing. Of course, some of you will have this information already, and I won't spend too much time on it. But I do want to provide some background because, as we saw with even a number of our keynote speakers, a 3D graphics format that's ISO ratified and has been around for 20 years still seems like an obscure thing. Okay, so I want to make sure that we all have a common start here, which is about X3D and humanoid animation. These are the current standards that we're developing, but as you've learned from the last 2 days, that X3D is a compatible evolution from VRML. Right? It's a similar scene graph, and actually before that, it was something called Inventor, okay? The principles of a transformation graph and a behavior graph, right, are built in to this standard, okay? So we saw a little bit about something new, GLXF, not sure, but we've been composing standards and declaratively wiring up interactivity for a long time. We've learned some things, but the best part about it is that it still works. Okay, so one of the things that we'd like to do with this session is to begin a conversation with you, some of the new faces that are here, and try to understand, what the consortium could do for you. Okay, the consortium is a member-driven organization, and that means that the members drive the focus. Right? The projects that we work on. If this is something important, well, now you have an international vehicle, a venue to bring that technology and to integrate it with the ecosystem, okay? And this is actually a very good leverage, and we've seen over the years dozens of very excellent, capable companies experiment, build, use the extensible standard, right, to prototype and build their systems. And once they found that sweet spot, go and commercialize it. And so it's a very high benefit, low risk strategy in terms of developing content and a business. So these problems still will change. And that's why we continue to look for our members and to ask them, what should we be working on? What are the hard problems to solve today? Okay. So obviously I've intimated a little bit that this is a mature standard, right? And if for sure, any kind of customer who needs something to last 10, 15, 50 years, for example, a nuclear power plant or a building or a ship, this is not something that you just sign over to a Silicon Valley company, right? And so you'll see actually a lot of governments, a lot of science, engineering applications. Okay, so maybe it's not the mass market that everyone is sort of imagining that 3D should be, but the fact of the matter is we've been getting a lot of work done over the years, and all of that work is still running and relevant, okay? So this is a fun story. I love this slide, and you may have seen it in different forms. But since the ISO specification of virtual reality modeling language, VRML, where this scene graph was introduced, a content model that describes objects, materials, lighting, animations, and behaviors, interactions, it's evolved. And since the late 90s, as we've seen, the early metaverse prototypes, right, characters were really an important piece. Okay, so humanoid animation is an ISO standard also that describes the joints and hierarchy of the human body, okay, for different levels of fidelity and articulation that you might need. HNM 1.0 was basically like kind of segmented characters, right? You had the arm bones connected to the shoulder bone and connected to, right? But it became clear that there were some new ways of describing and rendering human characters, for example, skins and bones, and then various kinds of displacers that would work on the skin as you were moving the skeleton. Okay, and we're going to see some great innovations from HNM today, because HNM 2.0 includes BioVision, the BVH motion capture standard. And we know that our colleagues at the Web3D Korean chapter have been organizing a really great contest called the HNM Music Video Contest. We're going to see that later at the end of the day today. So the standard has continued to evolve, and as you know, we don't really, there's all kinds of places where our members and open source communities add value on top of that, right? So we had open source tools like XJ3D, FreeWorld, Castle Game Engine. These are open source, robust, performant engines that load X3D and will let you to customize and build, right, whatever sort of application or front end that you want. And there's also a number of really capable commercial tools, and you might see bit management there, but certainly instant reality from the Fraunhofer IGD is a major player in terms of the engine and the support of this rich standard. Well, to get to the web, it was difficult, but now we have WebGL. It's on everything, and we can literally build a X3D browser with JavaScript. This is a game changer, and we have two of those open source out there: XFreedom and Excite. So we're happy to have them in our community and to have our community contribute back to those code bases. As I mentioned, my students have contributed several features into XFreedom. Okay, and HNM2 is a recent development, as I mentioned, and includes BVH motion capture data, being able to integrate that. 3D printing became a real topic, and especially during COVID. Folks have not seen the National Institute of Health in the United States, NIH, right? They adopted X3D for their enterprise website. You can upload lots of stuff. You can, everything from the molecule to a petri dish that you might need, or a lens to mount on your microscope for a camera, or COVID PPE, which was the case. That's all in X3D, and indeed, X3D can be printed directly with tools like Cura, open source tools. So it's been a great evolution, and I'm really pleased to have been a part of it for a number of these years, and I hope to continue that 27 years and counting, right? Okay, so we've seen a lot of this in the examples and the discussion already. Yes, it's ISO. Yes, it's proven. Some of the things that we do internally is we have a process that we don't send anything to ISO unless it has 2 implementations, right? So we had a little bit of discussion about, do you standardize something before it's ready? You know, maybe our perspective is it does need to reach a certain threshold of confidence before we're going to take it to ISO. And through our working groups, we've been able to hit all kinds of different verticals. We saw this one before from Anita, the greatest common denominator, okay? Oh yeah, well, if it doesn't have that particular material property, it's cool. X3D, you can extend it, okay? Make your own node. It'll still validate, you know? And if you have control over your open source engine, you can implement it too. So this is the way that innovation happens. We're not talking about specific platforms. When you touch something or drag something in X3D or VRML, it doesn't matter if it's with a 6 degree of freedom handheld device, with a phone or with a mouse, okay? The behavior is still the same. So it's actually a very capable across different kinds of platforms, including immersive ones like my cave, where I run the exact same content that I run on my phone. Here's the breakdown of kind of the different things. And again, these groups are driven by our members, right? So when it becomes important for someone to be processing, rendering, dealing with geospatial data, there's a working group, and there is a community that starts to work on that particular vertical and come up with a solution. So you'll find in the X3D spec, there are actually components for volume rendering, geospatial data, and tiling, and so on. And these are the direct result of our member-driven agendas and our working groups, okay? So that's really what I wanted to express, that it's very capable, but we're only going to work on what our members want us to work on, okay? So the big news is X3D4, right? We've been maturing and building out X3D3 for quite some time, but what's really exciting here is that we've added a number of really, I think, relevant and key features. We're able to, of course, match and include GLTF scenes. Okay, well, we've been composing 3D models from across the web for years. Now it can be not only another X3D file, but a GLTF. It gets lit. You can use X3D for the shadows. You can use X3D for the interaction, but still that JPEG, right, is you want to do something with it, right? You want to put it into space. So it's a really great bootstrap for us and to build rich kinds of worlds. Again, physically based rendering, that's not from us, right? There are experts in the world that have studied that, built it. We just get to use it because we're playing in the standards world. All right, so there's a lot of new features in here. We also mentioned web audio and things in X3D4. So this is now under ISO ballot, and we should have an approval here. I think all of the national bodies have voted, so we should be seeing the results of this ballot very soon. I should mention why that's important. Okay, right? This isn't just a standard that we decided to stamp and put out, for our own purposes. It actually goes through the process of ISO. okay, where it means national bodies, experts around the world, vet it, comment on it, and approve it, okay? It's not something we're doing in isolation. And in fact, this is what I would say the Cadillac of ISO standards. It's not going to expire in 5 years, okay? GLTF or Collada, they will expire in 5 years. Okay, so there's a fundamental difference, but we do want to play well with others, and we've expressed this at different points throughout the conference. Touch points, official liaisons. If you're the kind of person, again, or a company who really wants or has an agenda about, for example, medical imaging and health records, well, we have a seat at the table at HL7. And as a member of Web3D, we can make you an official liaison and give you that seat at the table. So in a certain way, you get like 8 memberships for 1. Okay, it's just if you're willing to put that in. Okay. So some new working groups recently. By using the web technologies, we get to leverage all that great stuff. You guys remember, know this guy called Tim Berners-Lee? Okay, the semantic web. Well, a number of our members have been publishing and showing great value of integrating 3D models and semantic technologies, and there's a working group actively meeting, building examples, testing things, sharing results in papers and so on. Web3D user experience, we had Anita's point the other day. It's like, look, we're all access impaired in 3D, okay? It's hard to get around. You get lost, right? You're not sure where you're looking, which way is up, right? So there are some really important things about user experience that we can study, improve, okay? And this is the working group that's working on that sort of aspects. And we have, again, a bunch of students around the world doing experiments to provide quantitative lessons of how the next spec should work. There are some, maybe not obvious, but great resources I want to share with you. webx3d.org is kind of a side site that we've set up for to help people find a way in. And then we've been producing, especially through the COVID, but it continues now, a series of webinars that are on YouTube. You can go and watch them at your leisure. But it's everything from how do I go from OBJ to X3D to more advanced kind of topics. And these are all ready for you and your team to learn more. So web3d.org is where we live. I'm not going to bother about this, actually, so sorry. Neither about this. But as you can see, it reinforces that point of we have a seat at the table, an official liaison with all of these different groups. And our mission is the web. We want it to make it work together, right? To harmonize it. Some of them are do have patented sort of technologies, but we have a proven process in Web3D to vet and make sure that that our standard is royalty free. Okay. So certainly this is a vibrant community. It's an exciting place to be, and the consortium as an organization can help you in a lot of ways, and not just technical development, certainly, or business opportunities, but also being able to, strategically drive the technology in a long-term kind of way. And as you can see, we're going to, we've been at SIGGRAPH, supercomputing, VR, all kinds of places, and as members, we're sharing the results of that that networking with each other. So it's very powerful. Okay, so there's a lot of things at web3d.org you can find. I encourage you to take a look and spend some time exploring that website. Okay, so something about the Web 3D roadmap. What do we have on the docket right now? And this is also a point where we can launch into a discussion and a little bit more about what people are doing and what our priorities are. But as you can see, we've been developing the X3D suite of standards, okay? And it's not just an XML format, right? There's also specified UTF-8 brace bracket type of style, which we refer to as the Vermal Classic style. Okay, there's also binary, so we can have the same scene representation encoded in different ways. This can be useful for different things. XML for security, binary for speed of transmission, so on and so forth. What's really pushed this specification and standardization effort is the development of a unified object model. Okay, our nodes in Scene Graph work in an inheritance hierarchy. And what we can do is with that basic model, we can generate a Java API for it, a JavaScript API, Python, C#. This is all consistent because, again, we're using computer science information principles in the generation of this standard, okay? And that's a really powerful thing for scaling. Putting it into the web and being a first-class citizen is also really key. And for sure, X3D4 has, we've done some really deep dives on how do we make this HTML5 compatible? How do we work with the DOM as another sort of API, if you will, and mix the 2D, 3D content and all the information services that the web provides, okay? We have done a bit of work. Actually, our colleagues and members in Korea and in Germany have been worked on how do we extend X3D for augmented and mixed reality. There's some interesting things there. See-through cameras, different kinds of poses, as we mentioned. We came up with a spec once upon a time, but frankly, as we were a little ahead of our time. And now with something like WebXR, this is a great time to revisit this X3D 4.1, okay? Humanoid animation continues to be developed. And as again, we'll see some great examples of that later today. One thing I should also mention about this liaison activity, if you are a large company with an infrastructure, thinking about digital twins, smart cities, these ISO standards becomes very important. And indeed, our 3D printing and scanning group is very actively engaged with other sorts of groups that might be doing things like STEP, right? IFC, these other kinds of standards, which are great for their application. But if you want to visualize that now, we need to find that compatibility layer. Okay, so I'm going to leave that up for a little bit. And I think that we have a few of our board members in the room, actually, and I'd like to introduce them. So actually, we'll start perhaps with our general chair host, Christophe Mouton. Could you have a microphone, Anita, please? This one. Anita, yep. So I would like to introduce Christophe Mouton, a board member of Web3D. And just maybe to introduce yourself, and if you wanted to mention a little bit about why working with the consortium is a value to you.
Thank you very much, Nicolas. So it's my pleasure to share that EDF, so the French National Power Utility, is member of the Web3D Consortium now for, I will say, more than 15 years. So we started in 2005. I recall that in 2003, we host in France, in Saint-Malo, the Web3D conference. And I was a young R&D engineer at EDF, and it's how I discovered the potential of standards for interoperability for virtual reality application. Oh, sorry. Yes, you suggest that. Yeah, sorry. So yes, I think that it was a key discovery for me when I was a young R&D engineer at EDF. It helps me so much to find this layer of interoperability, how to exchange data. At this time, you remember, I was doing scientific visualization. And I would like to share at this time the data that my colleagues are computing on very high performance computer, and it was a real nightmare to be able to find something stable to produce the data and then to visualize them. And after that, I joined my colleagues at the new nuclear engineering entity, and it was the same thing. We have this huge 3D mock-up for our new nuclear power plant, and none of my colleagues have seen the whole mock-up in the same time. We just see building by buildings. And that's how we work with our colleague from Fraunhofer, now the 3D company. And it's now, I will say, since 2018, we are able to visualize, thanks to the Web3D technologies, the full power plant of the EPR, so the one that we are finishing in Flamanville and that we are building in UK, and that we have also one in China. So yes, it's very practical and with small projects. Thank you.
Wonderful. Thank you, Christophe, so much. And it's been a pleasure to work with you all of these years. I really appreciate that. I don't know if you would mind, you mentioned, you know, a very important group that's in the room and also been a member for decades, perhaps, our German colleagues from Darmstadt. We have another board member here, and Web3D magician somehow, I think, Johannes Beer.
Yeah, hi. So my name is Johannes Beer, and I'm now with 3, but it's just a recent movement 2 years ago. And I started doing virtual reality actually in the mid-90s, and there for mainly industrial application, and so starting in caves and with this really huge SCI machines and everything. And there was always a challenge how to get application into the different setups and everything. So we were looking for some really abstract scene description that allows us to build really interactive and yeah, but on the other hand, really complex application. That's the reason why we looked at WebAR at that time and have built one first, virtual reality system that has used WebAR at that time to run the whole thing. So that was a really interesting experience. But what's challenging was that the industry was really moving to web-based applications. So we were looking into something different. So EDF was just one of our customers. I said, oh, X3D is cool, but can we do it without installing anything? So that was the reason when we started to look in X3D, and that was a really interesting experience because all the web guys that were actually working on application that were sitting on this DOM layer and including X3D, so that was a real push also for us. So we joined the Web3D consortium right at that time, about 10 years ago. So there were always some missions, some extra parts and pieces that we moved around. And we also joined now as the company, right, just 2-3 months after we started company, because for us it's super important because we rely on the accessibility and addressability of data in general. So it's not so much about people, but it's really about tech, and they're having standards that allow us to do this for years and without really having to reconfigure anything. That's super important. And that's the reason why we, for a lot of customers, really they point them to X3D. They use X3D as EDF, for example, for the compositing of data and everything. And so that's really important. So, and that's the reason why we are here and why we joined.
Awesome, awesome. Thank you. That's a great testimonial for sure, Johannes. And I think that's does get to one of the key sort of value propositions of this organization and the membership is, if your strategy includes like a long-term view, like maybe you want to have a stable tech platform for more than a few years, I think we should talk. Okay, so we have just a few minutes. I'd like to invite another board member up who has a very exciting announcement as well. Jorge Posada from Vicomtech.
Okay. Hello, everybody. So I am Jorge Posada, the Associate Director of Vicomtech. We are an applied research center working on vision computing, interaction, and artificial intelligence in San Sebastian in Spain. We have been part of the consortium since already several years. I don't remember exactly when we joined. And the reason is the following. So we have heard the testimony of already a user. Okay, first of the consortium itself, which is fostered and promoted by very good universities and also companies, okay? But we heard the testimony of a very important user, in the case of Crystal Mouton, of a very important technology provider, in this case, which is 3D. And I would like the testimony of the applied research is the one that I can convey. So in the applied research world, it's very important to have, you know, one eye on what is coming from the research, what is coming from the standardization, what are the new trends, and the other eye on the real needs of companies, of industries, okay? So we are constantly looking for both things. And I think the Web3D Consortium is an excellent place to have both of these interests together. Yeah? So that you have what are these new standards, what are these new basic technologies, what are these new ways to conceptualize and to provide Web3D content, but also to see what companies are really needing, okay? So we are all aware that the market doesn't always move in the same, let's say, lines that the basic research is promoting or the standardization is promoting. There are standards de facto, companies come and go, and so on. We have to be very aware of that and be flexible. But a community, and this is what the Web3D Consortium is, a community, okay? A community where there is a neutral place, so to say, to contrast all these different views is, I think, an excellent forum to have this common understanding about what's going on, okay? So the fact that it's promoting standards is a great thing. I think it's an excellent thing. We should also be aware the world doesn't move only with standards, okay? That's also true, so we have to be realistic on that. But the long-term view, I mean, I don't know how many years you have been there. I even remember as a young researcher, I told you this yesterday, I used the first VRML specification to do an avatar like was moving like this, okay? But I did it already, it was possible. So I think it provides a lot of value. So we organized in Vicomtech, I think, a very successful edition of the Web3D conference in 2013, okay? That was a great event. I think everybody has excellent memories of that edition of the conference. And the announcement that Nicolas is mentioning is that we will really like, and I think this is already the common understanding of the consortium, to promote Vicomtech as the host for the conference in 2023. So that will be exactly 10 years after the edition that we had until 2013. And I will be really pleased on welcoming you all in San Sebastian. Thank you.
Yeah. Wonderful, wonderful. Thank you so much. Vicomtech has been a great contributor technically and also culturally, and we're very excited to go back next year. Thank you so much. Okay, so we were going to Anita probably has some parting words, so go ahead.
Again, thank you all for attending, and I've been with the consortium for a little over 10 years, and I work with great innovators, and like all our board members just mentioned, it's a community where information is shared, relationships are developed, businesses are formed, Okay, I'll stand here. So as you can see, EDF as a user partnered with one of our members that's developing 3D. And then we have research also happening. So it's not just coming here to work on technology, it's building relationships, finding partners. And it's a grassroots organization. Some people think it's only research. No, it's not just research. There are a lot of applications, and it's more for serious 3D, enterprise 3D. So if you really are interested in preserving your 3D content and you want to use a standard, this is a place you need to be. At least come and explore what we are doing. We are here. We are very welcoming. And I just want to thank the committee here, the Web3D 2022 committee, Marius, Christoph, Indira, Patrick, Christian, who was a webmaster who's not here today. And most importantly, all the students here, we hope someday you guys become researchers, build companies, and you will want to sponsor an event. You will want to come and join the consortium. So because I think as a student, it's very important to be exposed to these events, meet innovators, and this is going to really improve not only your studies, but your careers too. So we have is it Zeed? Is he here? Okay. And then we have Abby, who has helped us a lot. She's not here too, but I really wanted to acknowledge all the students here who have helped. And Marius, your team has done a great job. Thank you so much. This has been a successful hybrid event, and we hope to continue this format in the future. Okay. Thanks again.
Okay, thank you, Anita. Great. So I look forward to more discussions with you. I believe we have still a great program this afternoon, industrial use cases, and then some awards. So stick around, but now I think it's perhaps time for a lunch. Okay, so I don't know if there's anything special, Marius, you'd like to share before we head over to the cafeteria?
Yeah, just to note that we also have a workshop in the afternoon. So a workshop, industrial use cases, that will be in the same setting as this morning, fast forward presentation here and demonstrations outside. And then we have the award ceremony. Stay here. But now let's go for the lunch. Yeah. Yeah, let me see what's time right now. Yeah, it is about, yeah, let's be back 15 minutes after 1. Yeah, in 1 hour. Okay. Yeah, please take your computers with you.